Hi class, Mr. Watlington, how are you doing? Welcome to week 1 of CIS 225, Network Routing and Protocols. A great class, an exciting class. I always get pretty hyped when I teach this class. Why? Because one, it's a lot of material you're going to cover in this class, but at the end, I think you're going to get quite a bit out of it. You're going to learn a lot of the basics, the foundation, the core things you need to know to understand networking, routing, and the various protocols. One of the things that I do in this class is help go through some of the guided practices. The way the class is set up, you've got, like I say, each week several assignments, but specifically there's a project. And this project is a weekly project. It's iterative. You're going to build on it from week 1 through week 5. Now, to help get you, the class acclimated to what the project is looking for, we have what we call guided practices. There's a guided practice in each week. The guided practice is what gives you the skills and the tools to be able to do that week's portion of the project. So what I'm going to walk through with you now is just a tutorial on the guided practice, which is really a tutorial on how to build a project. Okay, so what this project is, we're going to start with a single building. We're going to build a network for it. Then we're going to add a second building. We're going to connect routers, route between those buildings. And then we're going to add another floor to that building. And we're going to secure the network, okay? As well as learn how to troubleshoot the network. That's what we're going to do across each of the 5 weeks. So what we're going to cover today is exercise or assignment 1.10, the guided practice, how to build a small network. A brief overview. Well, we're going to take this. This is going to start small, where we're going to have one router. This is all Cisco components. A Cisco 4321, 2 switches, 2 9660 switches, and 2 PCs. And we're just going to connect those together in packet tracer, and so that they can communicate with each other. However, before we can do that, we've got to learn how to configure IP addresses so that we can have the right IP addresses across each of the subnets. Now, some of the skills you're going to review, some of the things that we're going to cover, how to subnet, how to identify gateways, your default gateway on your PC, how to connect packet tracer with a straight through cable, as well as some of the new skill sets of identifying ports on routers and switches, and how to connect up a console cable. And what this console cable is for is that day to day, if you look at a typical router, like your router at home, it doesn't have a keyboard, mouse, or a monitor. So how do you configure a router? Well, to do that, that's why we would log into that router through some type of remote device, some type of of a PC that now we can connect up with a RS-232 connection and remote into the router, so we can actually configure it. Okay. Now, so we're going to walk through how to do that as well. Well, you're going to learn quite a few packet tracer commands. These are some of the basic ones, and the shortcuts like enable. Like I say, when you first go into packet tracer, you're going to see it's like a less than arrow, which is the cursor. Well, to get into the global configuration mode, you have to go into enable. Then to configure a port or to configure an interface, you have to go into the configure terminal mode. So there's many modes and many commands. These are just a few of the basic commands that you're going to use quite a bit, such as if you want to see what your configurations look like, that's what the show command. Now, there are many different iterations of the show command. You can do a show run. What that's going to show you is the running configuration of the router. You can show IP route. What that's going to show you is all the IP routes that are configured on that device. So many things that you can see from that perspective. Okay, so we're going to talk about subnetting. Now, subnetting, I will tell you guys, this can be the bane of your existence if you're trying to within this class. Many people catch on to it quickly, some not so much. What I try to do to help with this conundrum is I love analogies. Now, an analogy that I love to use is my bingo subnetting analogy, right? What is that, you might ask? Well, let's forget everything you ever known technically about IP addresses or whatever. And let's talk about bingo, B-I-N-G-O. All right, so here we go. I am the owner of a bingo hall, okay? I just purchased a bingo hall, and it's just one big room, and it has 256 chairs. right? So now I can set all my chairs up in that big room and start playing bingo, right? Yes, of course I could. But as everybody knows, if you're a bingo player, there's two people that you need to have at any bingo hall. You're going to need to have the person who calls the numbers and the person who goes around and checks the cards when somebody says bingo, to be sure that they actually won. So those are two chairs that I can't sell. I can't assign those out for people just to play. So the first chair and the last chair, right? Can't use it. So I have 254 chairs that I can sell, that I can have people come in and play bingo in my hall. So basically I have one large increment, right, of 254 available chairs to play. Well, in the course of time, business is doing well. And I noticed that some people, they've talked to me and said, we want to play higher dollar games. Meaning that, because normally I just sell my cards for, $2 a piece. Well, and which means you're not going to make as much money. So now some says, hey, can we play a little bit? Can we up the ante? I said, sure. I want to have a place where I can sell cards for $5. But I can't do it all in one space. So what do? Well, I subnet. What I do, I put up a petition in the middle of my room, split it right in half. I got 128 chairs on one side, 128 chairs on the other. This is my $2 room. This is my $5 room. Okay? Now, the thing to remember is, like we said before, with bingo, you always have to have a caller and a checker. So in each room, the first and the last chair I can't use. So now I have 126 available chairs in this room, 126 available in the other room to give out. So I basically split my room into two increments of 128 with only 126 usable or available chairs in each room. I've just subnetted my room by 128. Well, in the course of time, things are still going pretty good. Now I've got other people who wants to say, well, you know what? We want to play even higher dollar cards. I say, wow, okay. How do I do that? Well, I could continue to subnet this room if I wanted to. I could just keep dividing this up. But that's something we're going to get into next week, how to continue to subnet that. So now that we know how to subnet into two categories, now let's switch over to our guided practice, okay? So now let's do this. Now we're going to move into the world of IP addresses. So to create subnets, very similar process. We're just using ones and zeros, okay? So let's take the IP address that we've been assigned, 192.168.x.0, and that slash CIDR of 24. Now, if you remember, that X is what you're going to be assigned. If you look into the announcements, there should be an announcement you're going to see that's going to have your name with a number beside of it. That is your X number. That number you're going to use in the third octet of a lot of your assignments, your guided practices, as well as you're going to use that same X value in the project. So for me, I use 10. As an instructor, I just use 10. So 192.168.10.0 CIDR 24. So that means there's 254 usable IP addresses. That's what that CIDR 24 is telling me. So I want to divide this up into IP address into two subnets. All right. So what I like to use is a simple little table like this. There's many ways you can do this, but this is just a table that helps me out. So because it pretty much gives me everything I need in one snapshot. It gives me how many bits, the CIDR. And like I say, right now this IP address is /24, which is just one big increment. Now this also shows me if I continue to look at the CIDR, it will tell me how I can subnet. So, and CIDR, if you remember, on an IPv4 address, it's the total number of ones you have in that IP address in the net. Like I say, there's 32 total bits in a IPv4 address, and the CIDR is how many of those are ones. In this case, there are 24 ones, and the rest of these are zeros, and those are the hosts. Those are the hosts that can be assigned. So for this one, I can assign 254 hosts right now. But that just gives me one big subnet. I want to split this in half. So to do that, I have to borrow a bit. Or when we say borrow, basically we're going to take one bit and we're going to flip it to a 1. We're going to make it a network instead of a host. So in this case, and this is another little handy dandy table that I like using because it shows me really very simply how many bits do I need to turn to 1s to get how many X amount of subnets, okay? So if I look at this, if I want 2 subnets, I just have to turn 1 bit to a 1. If I want 4 subnets, I have to flip 2. And on down the line incrementally. If I want 32 subnets, I would have to flip 5 of these bits into 1s. In this particular case, how many? We want 2 subnets. So now I am going to take this cider, this next bit, make it a 1. So the cider becomes 25. And as you see now, my subnet mask 255.255.255.128. So that's what I've done to make 2 subnets. To divide that in half, I take the first bit, make it a 1, and the rest of them can be hosts. But I can only have 128 hosts in each subnet, okay? So a cider of 25 contains 2 subnets with 128 each. Now, as you see, the number of chairs in my bingo hall never changes. It's just how many rooms do I put the chairs in. Here, I'm taking 256 chairs, and I'm putting them in 2 rooms. Whereas before, I had 256 chairs all in 1. The same thing here. I'm taking 256 IP addresses, and I'm putting them into 2 separate subnets. Now, with each of those subnets, because I have to always subtract 2, I only have 126 usable in each subnet. So if I take a look at these subnets, what do they look like now? So my first subnet, the IP address is going to be my original IP address that I started with, 192.168.10.0. Remember, I can't assign the first and the last host, right? So my first assignable is going to be .1. My last assignable, .126. The broadcast address, which I can't assign, is .27. So if you look at it from 0 to 127, that is the 128 IP addresses. So that is what my first subnet looks like. That's what the subnet ID is going to be 192.168.10.0 cider 25. The subnet mask, as you see, 255.255.255.128. That's going to be the IP address range of the first subnet. Now let's take a look at that second subnet. Okay. Now, what is the subnet ID for my second subnet? Good question. Well, easy way to think about this. If my last IP address I used for my first subnet was .127, then the next IP address, .128, is going to be the subnet ID. That's where it's going to start for the second subnet. Just like in my bingo hall. If I put the first 127 chairs in one room, when I go to the next room, I got to start with chair 128 and go all the way to chair 255. So 192.168.10.128, that is the subnet ID of the second subnet. Now the first assignable host, which is going to be the next IP address, is .129. The last assignable host, 2.254, and the broadcast is .255. So now as you see, I have 2 subnets. The first one has 126 usable IP address, 1 to 126. The second one has 126 usable IP address from 129 to 254. 2 subnets, and I've divided that out. So now we can start to build a network. This is the first thing you always want to do. And learn this early in the class. Is good documentation. So before you jump into Packet Tracer and start trying to load IP addresses and build things, build it on paper first. Because if you build your IP address schema properly, and it makes it so much easier, because otherwise you're going to have IP addresses overlapping and you're going to have problems. You're going to be up until 2 o'clock in the morning Your significant other is going to be mad at you. Your kids are going to hate you. Your dog is going to bite you. You're going to be trying to call and email me after hours. And see, your whole life is just going to fall apart. So that's why I tell you, always do your documentation first. Lay out your network on paper before you go to Packet Tracer. So now we've got our two subnets. We know what those are. Like I said, our subnet ID for the first subnet is 192.168.10.0. Subnet mask 255.255.128. The ID for the second subnet is 192.168.10.128. And the subnet mask is, again, 255.255.255.128. All right. This is what your network is going to look like. You've got a router. That's that 4321 router. That router has two interfaces on it. Gigabit 000, gigabit 001. This interface is going to feed this subnet. We'll call it subnet 1. This interface is going to feed subnet 2. So let's take a look at subnet 1 first. All right, we know what our IP address range for subnet 1 is. The first usable host is .1. The last usable host is .126. So what am I going to do? I'm going to take the first usable IP address and I'm going to assign it to the router, to the gigabit internet interface on that router, which is, router 1, gigabit internet 0/0/0, and I'm going to assign it the 192.168.10.1 IP address with the subnet mask of .128, 255.255.255.128. Now the PC on this subnet, right? That PC, I'm going to assign it the next IP address, which is .2, and the same subnet mask. Nothing tricky there, right? That's how we set up our subnet. That's how we apply the IP addresses to the subnets. Now, when we take a look at subnet 2, we're going to use the other gigabit internet interface on this router, which is the gigabit 0/0/1. Okay, so same thing. We're going to give that interface. Here again, you got to remember, this is on the other subnet. This second subnet, the first usable host is .129, and the last usable host is .254. So I'm going to give that first usable IP address, .129, to the gigabit internet interface, and I can give, really you can give any IP address. For the purpose of this class, we skipped one. We skipped over to .132. Why? Just to let you know that they don't have to go sequentially, okay? It's a good business practice to do that, but you don't have to. So for PC2, I'm going to give it .132. So there we go. And again, the subnet masks for both of those are 225.225.225.128. So this is how I would assign my IP addresses to each of the interfaces on the router, as well as to the PCs on the router. Now the switches here in the middle, you don't have to worry about those. Those switches are operating as a layer 2 device. And these layer 2 devices do not have an IP address. They are looking at the MAC address that's connected. So we're not having to assign an IP address to the switches. It's just this layer 3 device and our hosts that we are assigning IP addresses to. So this is now how we would build that network. Now, one of the things, like I said, as we set this network up, I talked about it briefly earlier, is to set up a terminal interface. A terminal interface. What this means is that that we're going to use a PC. Well, I'm going to use PC1, and we're going to connect PC1 from the RS-232 connection to the console connection on the router. To do that, like I say, you're gonna and we're gonna go to Packet Tracer, and I'll show you this. But what you're gonna do is you're gonna go to that PC itself, go to desktop, and when you get there, you're gonna go to the terminal configuration, to the terminal mode. It should be populated automatically, and once you connect the cable, you hit OK. You should be able to connect to that router. And what you're going to see there is the exact same thing that you would see on the router itself, is how to do that. So let's talk about routes, okay? Because these are two separate networks, two separate subnets. And this router is what's connecting these two subnets together. So when we look at a router interface, and we look at, if we just type a command, show IP route, it's going to give us some information here. Let's walk through what we're actually looking at here. Well, we see on this top line, it's telling us that the original IP address that it's using is 192.168.10.0/CIDR24. It's also letting us know that there are 4 subnets. You're going, 4 subnets? No, you said there were 2 subnets. No, there is actually 4 subnets. Here's the 2 connected subnets here and here, but there are actually local subnets on the interfaces of that router. So that's what the L and the C is telling us right here. C is a connected subnet. L is the local. And if you look at the L, you see a CIDR 32. Well, this is saying that it recognizes that there are 32 possible or 254 possible IP addresses that could be connected here. Now, on the connected side, it knows that CIDR 25 is saying that there's only 126 of those IP addresses that are actually available. So that's your connected and that's your local. So that's what it's showing you. Local, like I say, is assigned to the router interface and contains all of the 256 possible available IP addresses. Whereas a connected subnet, that is a network that's the host or devices that's connected to that local network. So these are your connected subnets and then your local subnets. So let's go to Packet Tracer. I just kind of want to walk through this with you quickly within Packet Tracer itself. So this is what your Packet Tracer is going to look like, right? When you have everything connected. And now we talked about the console cable, and really this is what that console cable is going to be. This blue connection from the from the PC, and that connection, like I say, is connected to this RS-232 port on the PC on one side, and it goes over to the router, and it connects to the console on the router. So when we go into our PC, okay, so like I said, we can go to desktop. And if I go to terminal, it's like I was showing you on the PowerPoint, but this is actually in Packet Tracer. All of this should be set up. It pops up automatically. So when you hit OK, well, now we're actually looking at that router. We can make that a little bit bigger. This is all the startup information for the router itself. Now, some of the things that we had talked about as far as what you're going to see when you first log into this router, when you are at this prompt, you can do a few things with there, not a lot, but you really want to go into the privileged mode. You want to hit enable, and you see that our cursor, our login prompt changed from that less than hour to the pound sign. Now here I can now look at the configuration. If I wanted to configure the router, or if I want to look at, I can do a show run, and it will show me the running configuration of this particular router. Like I said, I've already got this network set up, but this is what it shows me, that on Gigabit Internet Ethernet interface 0/0/0, IP address 192.168.10.1 with a subnet mask of 255.255.255.128 is loaded into that, as well as it shows me what's on 0/0/1 IP address. I don't have any VLAN set up, and really not a lot of things configured in this router at this point. But that is what your router actually looks like. And I'm looking at this through the PC. This is PC1 that's logged into this router. Now, looking at the PC itself, if you go to this Configure tab, some things that sometimes people get confused on is your default gateway. So if you look at the settings, this is at the Settings tab. It shows you that with the static IP address 192.168.10.1. And now, that is the default gateway, meaning that that's the IP address of the interface on the router. The IP address for the PC itself you go to the Fast Ethernet 0 subtab on the left, and you see I have 192.168.10.2 loaded into that with a subnet mask of 255.255.255.128. Now, one of the things you always want to be sure when you're looking at these interfaces is the port status. Be sure that that is always checked on. You see what I just turned that one off, and as you see, the link went down. We lost that link. Why? Pretty simple. My interface is turned off. So I want to be sure that's always turned on. Now, you see I turn it back on. I got a little green, the green arrow here, and the little orange dot there. Well, this PC is handshaking between the switch and the PC. That takes some time to do that. And if you want to speed things up, just go down in Packet Tracer, click on that little fast forward arrow, and see what it does. It automatically makes things link a lot faster. So that is how your PC connects. So likewise, if we want to, and here in Packet Tracer, I can just click on the router itself and go right into the router, right? So you know that is not a problem. Excuse me. But one of the things that you want to always be sure of. Now, as we walk around Packet Tracer, like I say, here's a physical view. If I click on that physical tab, it gives me a physical view of the back of that router. Right now, it's pretty boring. There's not a lot going on with the back of this router. Next week, in week 2, you're going to connect up this NIM2 card, which is going to give you some serial ports, but that's in week 2. If you go to this configuration, this kind of gives you a GUI method of configuring ports and everything. Now, but what it also does, and it's a great little handy, kind of a handy cheat sheet, it gives you the equivalent CLI command. So anything I do here, you see it's going to pop up. So if I go to gigabit 001 and I turn the port status or the interface off, bam, you see what happened? It automatically gave me what the actual CLI commands where you're going to be doing most of your programming, which is right here. So as you see, even though I clicked that little button off, basically what did it do? It told it to shut down. That command shut down. If I clicked it again to turn it on, and no shutdown. So when you're going through the assignment, always be sure that you type in that no shutdown. That way, after you configure the interface, that way you know that the interface is actually turned on. So that kind of gives you an idea of what your packet tracer should look like. And once you get everything connected, and if you, I just added these text boxes here. Not that difficult to do to add the text fields actually, and but this is more for instructional purposes. Now I should be able to ping from PC1 to PC2. Now the IP address of PC2 is 192.168.10.132. So I can go back to PC1, and what I'm going to do is go to desktop. I'm going to close the terminal, and I'm going to open the command prompt. And at the command prompt, I'm just going to type ping, if I spell it properly, 192.168.10.132. And sometimes it takes a minute for all the handshakes to take place, but there you go. You see reply. And whenever you see that reply, that means your ping is working. Now, something else to remember, it kind of gives you a little advantage. Your up and down arrows. If I want to ping this again, and I don't have to sit and type all that back in, I can just hit my up arrow, and you see it brings it right back up. And I can hit ping. Now, I'm pinging end to end, so that tells me that my router interfaces are working. But let's say that if I couldn't have pinged PC2, well, I would have methodically, step by step, tried to figure out where my ping stopped. So the first thing I would have done, if I'm going from PC1, whose IP address is 192.168.10.2. Well, let me see if I can ping .1, which is the gigabit internet interface's IP address. So I would go there first. Okay, yeah, that works. Now let's say if I can ping across the router to 128.129. If you remember, that is the IP address of the gigabit 0/0/1 interface on the router. And yes, so this shows you a systematic way of troubleshooting if you're not able to ping. So that way you'll kind of know where things went bad. So if I could have, let's say this ping was unsuccessful, then that would tell me that there was something going on with the router itself. So this kind of gives you an idea of how you can you're going to start setting up your network and try to be as methodical as you possibly can as you go through your network. Okay. So we've talked about quite a few things. Like I say, go on to take a look at them in Packet Tracer. We've talked about understanding routes and what are our deliverables. Now, every week when we do our assignments, yes, there are deliverables, things that needs to be delivered. For the purpose of our guided practices, there is a report, a Word document report that is with each assignment. The Word document as well as your Packet Tracer file is what you will submit, okay? You got to submit both of them. Please don't just submit the Word document or don't just submit the Packet Tracer. I need to see both of those, okay? And have everything filled out in your Word document. Likewise, when you do the projects, the same type of thing. You're going to have your Packet Tracer, the project report, which is an iterative report. You're just going to have one report, and every week you're going to add to it every week. You're not going to redo the report every week. Week 1, week 2, week 3, you're going to keep adding to that. Now, there are a couple of weeks you're going to submit some different things with the project, such as a Visio diagram and things like that. All right. So hopefully that, kind of give you an idea of where we're going with this class, with the guided practices, as well as with the project. If you have any questions, please don't hesitate to reach out. I am online Monday nights, 8 o'clock. No, 8:30. 8:30. Wow, I almost made a mistake there. 8:30 p.m. And that's Eastern Standard Time. And I am on Thursdays at 8:30. Now on Mondays, that is when we do lecture. On Thursdays, that is Q&A. All right, guys, have a great week. Have any questions, reach out.